let's talk about normalization. What is normalization? Well, normalization is the structuring of database tables for efficient storage and manipulation. This ensures that the database is easy to modify as the requirements change, and they do change. It also reduces the amount of storage of redundant and possibly inconsistent data. So let's look at an example table. This is an example table of a radio call log. So it's a table of radio contacts showing data about the contact, the time and date of the contact, information about the station that we contacted, and we'll show that for every contact. Here's what our table looks like. So we have date and time of the call. We have the call sign of the station that we were talking to. We have the band and frequency. We have the mode. Okay, so that's the transmission mode. We have the grid square, which is a locator, possibly the flag and the country, flag of the country, and the operator's name, and maybe a comment. We'll assume it's a comment about the operator for our purposes. So let's look at some of the elements of this table. First of all, it's made up of attributes. An attribute is a single value, usually stored in the column of a table. And we call this an attribute because it describes the main idea of the table. So the frequency, for example, is an attribute of a contact. Okay, it describes the contact. So we can see here that we have several attributes. We have the date of the contact, we have the time of the contract. These are all attributes. So one of the attributes, one or more of the attributes, is used to uniquely identify each item. So we treat these in a relational database as a set. And in set theory, a set is a collection of unique items. So a primary key is a unique attribute or group of attributes that can make each element of the set unique. So we ensure that the key is unique, therefore we can always find it in the database. So then we can use set operations to manipulate the data table. Various things like selecting particular rows and so on. So we can use this set theory to manipulate the table, and this is actually known as relational algebra. In some cases, as I mentioned, we may have more than one attribute making up the primary key. This is referred to as a composite primary key. So you can see in the case of a call, or a contact, in order to uniquely identify the contact, we would probably need to know the date and the time and the call sign of the station that we were contacting in order to make a unique identifier. So sometimes we have to use more than one attribute to do that. So why do we want to normalize in the first place? Well, one of the main things is to reduce the requirements for restructuring the database every time there's a change in the requirements. One of the things that occurs is called a repeating group. So let's say we had one station that we contacted, and we contacted that station several times. So we might say, well, let's add on another spot to put the next contact and the next contact and keep all the station data as it was. Sometimes you'll recognize this by things like date 1, date 2, date 3, frequency 1, frequency 2, frequency 3. The problem with a repeating group is it requires you to change the database structure. So you might set aside a certain amount of contacts, maybe 5. They take up extra space if you've only used 1. And if you run over the 5, then you have to rebuild the table, restructure the table. So the entire table, you could actually add an entire new table if it's kept separately. So the idea in a repeating group is we just put it in a separate table. So here's an example of a repeating group. We've had date and time, frequency. We'd also have the call, the band, and the mode, and we'd repeat all of those. This is just in the contact part of the table. and then we do it again for the next contact. So we get lots of extra data, and when we run out of space, well, got to rebuild the database. So we also want to avoid redundant data. We can see from that example, we're going to have empty contacts that we haven't made, and if we put it into a separate table, which we can do, or we put a separate entry into the table for each one, then there's going to be redundant data. So if it's repeated in multiple rows, it takes up extra space and it's difficult to keep it consistent. So here's an example. We have another call or another contact with K2 Romeo Oscar Hotel, and we just put another entry in the table, but maybe we put the station information in, but we don't remember where the original one was, so maybe we use a different name for the country, use an abbreviation. We don't remember the operator's name, we didn't get it. Maybe there's no comment this time, so we could have data that's for the same station but not really consistent. We also want to avoid something called an insert anomaly. This is where we enter station data each time and possibly introduce it inconsistently, like we just saw there. We've decided, well, we're going to put United States the first time, and then second time we'll just put USA. Well, if we're looking for that, we won't find them all unless we say, well, if we put this or if we put that, makes the queries complicated and inconsistencies in the data. We could also have some attributes that are missing. So we didn't know the operator's name, we didn't get it this time. So I think I talked to that person before, but I don't remember their name, and there was some noise, we didn't pick it up. So now we have one with the name, or maybe we spelt the name wrong, or we got it wrong when we heard it. So we could have inconsistent data. We also want to avoid update anomalies whenever we need to make a change. For example, we decided to put the country in as USA instead of United States, or we decide to put it in the other way around. Then we have to go looking for every occurrence of that to make sure that we were consistent each time we entered the data into the table. So we'd have to find all of the occurrences and update them accordingly. Okay, so you can see here we have different things, different notations for entering the country, and they're not consistent. So that's what we want to try and avoid. A delete anomaly, maybe we delete the last entry of some data and then we lose all the station data to go with it. So when you delete a contact, it's going to delete the station data. And if we have only one in there, let's say we took away the one with the good data and we left the one that has inconsistent data. And when we take away the last one, maybe we didn't make the contact or something was wrong with it, then we lose all the station data as well. Okay? So that's called a delete anomaly. So how do we go about this? Well, in the early days of relational databases, the gentleman that invented the technology, Mr. Edward Codd, he came up with some rules that we could use. I like to think about these as more a set of steps that we can follow to put our data into what's known as a normal form. So we have first normal form, second normal form, and third normal form. So each time we go to another normal form, we're reducing some of the inconsistencies. By the way, there are more normal forms, but in practice, we normally go as far as third normal form. So first rule, remove repeating groups. So we've seen repeating groups before. We want to place them into a separate table. We're going to choose a new primary key for the new table. And we're going to connect the two tables now with something called a foreign key. And that's basically a copy of the primary key of the related table. So that makes a connection between the two tables. So our new table looks like this. We've taken the data associated with the contact that was repeating. That is the date, the time, the call sign of the station, also the band, frequency, and the mode. We've moved that into another table, and we've identified a new primary key for that table. In this case, it's a composite key made up of the date, time, and the call sign. In second normal form, we remove attributes that are dependent on part of a primary key. Of course, this means that we must have a composite primary key, which we do, And dependent attribute is one that's likely to change when the primary key changes. So we call that a dependency on the primary key. That's how it's supposed to be. So the operator name, for example, is likely to change when the call sign changes because it's the operator of the station identified by the call sign. So this is what was left in the original table after we removed the contact data. And we see that we have the call sign. That's probably a very good choice for primary key of the, we'll now call it the station table. So the grid is the location, flag and country, they all refer to the station, the name, the operator of the station, and the comment on either the operator or the station. In third normal form, we remove attributes that are dependent on another key. So for example, the band is dependent on the frequency. So if it's a different frequency, then possibly a different band. But it turns out this could be calculated. So sometimes we'll have a situation where it's calculated, and the easiest way to remove it is to just store the frequency and calculate the band at the time that we want to display it. Okay, so here's our attributes here, band and frequency. They're actually related to each other. So probably we'd only store the frequency and calculate the band when we went to display it. So let's take a look at our revised tables. We now have two. We have the contact table and the station table. That's the names we've assigned to them. In the contact table, we have a new primary key. Remember, we had the composite key there. Sometimes if we have a composite key, we can get a situation where it's better to use what we call an opaque primary key. That's just a number, possibly a serial number. It doesn't have any meaning. That's what we mean by opaque. So it doesn't ever have to change. It just gets assigned to the contact, and it's the contact number if you want to call it that. And we also have to carry the foreign key to the station table to identify the station that was used in the contact. Looks something like this. So we have the new opaque primary key, just a number here. The data and the time, the date, the time, and the band, the frequency, and mode all become attributes dependent on the primary key, part of the contact. And the call sign is the call sign of the station that we communicated with. That's actually a foreign key to the station table. In our station table, the primary key is the call sign, so that's what makes the foreign key relationship. We store the primary key of the related table, and it looks like this. So there's a call sign, we have the grid, which is the location, and we have the country, which has a flag. We have the operator name and a comment on either the operator or the station. So that's all there is to it. Now you can go away and try it for yourself. I hope you enjoyed the presentation. Thank you.